Hello everyone, Aaron here and welcome back to Leetcode. Today we are doing the check if two string arrays are equivalent problem. Given two string arrays word1 and word2, return true if the two arrays represent the same string and false otherwise. A string is represented by an array if the array elements concatenated in order form the string. So ABC, ABC, ACB, ABC, these are different. A, B, C, D, E, F, G with two D's in it. A, B, C, D, D, E, F, G, two D's in it. Excellent. Okay, so fairly simple problem. Oh, it is an easy problem. So in Python, it's easy to the point of trivial. It's just dot join word1 is equal to the join of word2. I'm feeling super confident, so I'm just going to submit that. Yeah. So obviously that is correct. I don't think it's quite in the spirit of the problem, though. In particular, this is quite wasteful in the sense of it has to allocate an entire new string. It'd be very nice if we didn't have to allocate an entire new string. So what we should do instead is index through the arrays, basically. So let's do... basically what we want to do is create... basically we want to index into this as if it was a string. So let's do this as, let's say we've got def index indexter. We're going to have an offsets array and an index that we're indexing into, and a string we are actually indexing into. My microphone is wandering down. I need to tighten the boom for it. So we'll make this quick so it doesn't end up on my desk. So the way we want to index this is, the reason I want to say we've got some offsets is I don't want to have to compute the length of the strings. So to know this is at index 2, I don't want to have to know this is length 2 every time. So it'd be quite nice if this one was at offset 0 and this one was at offset 2. So actually, I'm not even sure that's worth it because I still need to walk through this offsets list to find where it belongs. Let's not bother with the offsets thing. So let's start with j equals 0. For w in s, j plus equals len w, if j is greater than I, in fact, no, hang on. If j plus len w is greater than I, return w indexed at I minus j. Otherwise, j plus equals len w. The thinking here is that if I've counted how far I've gone so far, if going to the next word would be too far, then I need to index into the current word minus skipping all the previous words. Otherwise, what I want to do is I want to increment and go around. If we get to the end, well, we've got a big problem. So then what we want to do is lem1 is the sum of len w for w in word1 word 2. Now we know immediately if len 1 does not equal len2, return false. Otherwise, we now need to start going through for I in range len1. If index_, self.index_word1 at position I does not equal self.index_word2 I, return false. Oops, I missed a capital up here. Return true. So this is our standard equality check. Check the indices, and if any of them don't match, return false. If you make it all the way to the end, they must have all matched, so return true. This is where it gets a little funky, is this index string business. We need to index into our string, in scare quotes, a little bit carefully, just because it will, we're being asked to do it in an unusual way for this problem. Let's submit it and see. Yep, there we go. So I'm not super willing to put much stock in these, as we've seen in the past, but it looks at a first glance like the original solution is faster. They use the same amount of memory, which is bluntly wrong, because this one here had to allocate an entire new string, whereas this new method does not have to allocate an entire new string at all. It just has to allocate a couple of integers and do some looping. Here, this looks like it would allocate n integers and then reduce them down to 1, but this is going to be lazy, so it's not quite that bad. It is only one integer or a couple of integers at a time that it's got indexed. Right, that is it from me. I am slouching down in my chair, chasing my microphone down onto my desk, so I'm going to leave it here. Do remember to like, comment, subscribe, all of that good stuff, and I will see you next time. Bye.